Welcome, my dear students. Now I am going to discuss about the horizontal range of the projectile. What does it mean and how can we find out the expression for the horizontal range of the projectile? Firstly, I draw the figure. X-axis, it is y-axis, and projectile launches its motion from the origin with initial velocity v0, and the angle of projection is, but the projectile motion is making, velocity of the initial velocity of projection is making with x-axis is alpha. Let the projectile is here at any point P having the coordinate xy. It means that the projectile has covered a horizontal distance x and the vertical distance y in time t. We are going to find out the total horizontal distance covered by the projectile from rest to rest. Of course, this is the distance covered along x-axis. So, it is covered in the total time of the flight. The formula which we know, we have already derived in the first part of the discussion, that the time of the flight is t is equal to 2 v0 sine alpha over t. It is g over g. So this is the total time of the flight from this place to this place, and this, the horizontal distance covered by at any time t is of course x is equal to v0 cos alpha into t. So if you want to find out the total distance covered, horizontal distance covered by the projectile from rest to rest is, can be just use this formula, t is equal to 2 v0 sine alpha over g. That is the total time of the flight, and we can use this formula here. We can put x is equal to capital R, horizontal range, that is the horizontal distance, total distance covered by the projectile, and t is equal to the time of flight 2 v0 sine alpha over g. We get R is equal to v0 cos alpha into 2 v0 sine alpha over g. We can write it down in a beautiful way as 2 v0 cos alpha into v0 sine alpha over g. This is a beautiful expression for the range, and that includes the horizontal component of the velocity as well as vertical component of the velocity, and is very much useful when we use to find out the range of the projectile in a moving object. Moving horizontally towards the target increases the horizontal component of the velocity, and in the vertical motion as well. So the same formula can be written in this way as well. v0 multiplied by v0 becomes v0 square, and 2 sine alpha into cos alpha becomes sine 2 alpha divided by g. This is of course the range of the projectile. This range totally depends upon, if you got this constant v0, it depends upon alpha, and the maximum value of sine 2 alpha is 1. We can have here, for the maximum range, sine 2 alpha is equal to 1. As you know that sine theta or sine alpha or sine 2 alpha, sine has got its maximum value equal to 1. So for the maximum range, we can substitute sine 2 alpha for 1. Sine 2 alpha is equal to 1 gives, implies 2 alpha is equal to 90 degrees and alpha is equal to 45 degrees. When this condition is met, that is when alpha is equal to 45 degrees or sine 2 alpha is equal to 1, this expression, the range becomes maximum. R maximum is equal to V naught square over G. In this particular case, we must keep in mind that the value of the alpha is 45 degrees. And we got that R maximum is equal to V naught square over G. This is called the maximum range, and that condition for the maximum range is that angle of projection must be equal to 45 degrees. A sort of the demonstration, when you water the plants or you use the pipe and the water in the lawn, you keep it horizontally, and when you just throw the water in the horizontal position and keep on increasing the angle of projection a little bit, you see that the range increases step by step, and you can see different trajectories made by the water. And when the pipe goes to the angle of 45 degrees, you can see that horizontal distance covered by the water in the lawn becomes maximum. And when we keep on increasing, when the angle increases even more than that of the 45 degrees, and the range starts decreasing, and at 90 degrees vertical motion becomes the vertical motion and the range becomes equal to 0. That's all for the time being. Thank you very much.